Hi everyone, before we get started, I would like to introduce myself, or if you watch the BRES launch event, I would like to reintroduce myself. My name is Guy Harding. I am heading up the drone side of BRES for this year. I am currently a third year aerospace student here at Brunel, and yeah, thank you to everyone who has joined the session or is watching it pre-recorded. Thank you for joining, and I definitely look forward to meeting more of you in person once the lockdown restrictions allow us to be working together on campus. Let's get into it. So, in session 1 of our introductory project, we will be going through a quick recap from the BRES launch event, a brief introduction into the health and safety involved with drones, and lastly we'll be going through part 1 of the introduction project. The part 1 of the introduction project is going to be a separate video if you are viewing it live. However, if you are watching this recorded at a later date, this will all be part of the same video. So the main project which we are going to be working on this year is our collaboration with NFU, which is a university in Taiwan. They are specializing in vertical takeoff and landing aircraft, like what can be seen on the picture on the right, which they have developed for a competition that they have within their country. And we are going to be designing and implementing the control systems for our own version of a vertical takeoff and liftoff aircraft to be implemented into the IMECI challenge, which is a more UK-based competition. In the left-hand side picture, you can actually see the current aircraft being worked on by the Brunel UAS Society, which is the main team which is responsible for competing in that competition. However, we will be developing the systems for implementing vertical takeoff and landing in future competitions. So the main project is going to be split up into 3 teams, which are each going to be specifying in a role. So you can be part of more than one team, and however, we do encourage you to just get involved with what you enjoy and work the best within that team, and we'll then integrate everything towards the end. So the 3 teams that we're going to be working with are, from the top on the right hand side is the team working on the programming and the parameters and the autonomous systems of the aircraft. This is a group which is mostly going to be led by me, as this is what I'm working on for my final third year project. So the next team is the electronics integration. Underneath the sleek body of most of these aircraft is quite a complicated control system and electronics. So it's important that we have, firstly, the correct electronics, which are power enough to handle the size of the aircraft for whatever role we are intending it for. So that team is going to be responsible for designing those systems, and we'll then integrate it into the aircraft. Lastly, there's the design team. They're going to be designing the actual aircraft. This is going to be done through CAD, such as Fusion 360. The taster project which we're doing is going to be an introduction to that sort of CAD work, which is doing an airfoil, and which will then be integrated into a full aircraft. So get involved with what you enjoy, and also you can get involved with other groups to learn something new. So besides our main project, we like to also just have fun as a side of BRES. We have our own aircraft which we just take out and fly, if the weather's good, and just make the most of the time in the university's facilities. We do have a full FPV racing drone race course with our own racing drones, which we are definitely looking forward to making use of this year. However, if you are beginning, we do have more simpler aircraft, more stable aircraft to learn on before advancing to those faster and more responsive racing drones. So always the fun part that we all have to do is the health and safety. I'm just going to keep this kind of simple and drone specific. There's lots of different health and safety aspects which you'll be involved with in BRES. However, I'm just going to be going through the drone side of things. I know a lot of it is not going to be applicable for the moment. However, we're just going to go through it and get it sorted beforehand so that when it comes to the actual fun activities, we don't have to go through it all again. So, firstly, is really specific to drones is propellers. They are surprisingly sharp, and when spinning at high revolutions per minute RPM, they are a real hazard. So when working within the labs, we remove propellers. If you are intending on powering up the drones without actual flight, we remove the propellers as well, just for safety. And besides that, just the more logical aspects of if a drone is flying in flight and the propellers are spinning, we don't grab it out the air or approach a drone which still has its propellers spinning. We first wait for it to be disarmed and propellers to stop before we handle any drones. So secondly, lithium polymer battery packs. So we use these type of battery packs to power our aircraft at BRES. They are high density for their size, high power density. So that means they've got a lot of power for their size, but that also has a negative aspect that energy, if used destructively, can be quite catastrophic. So we look after them. We charge them only using a specific lithium polymer battery charger, which balances and charges them correctly. They are handled with care, and if not in use, they're kept in one of our ammo crates. And lastly, if they are damaged or are not in a usable condition, we ensure that they are going to be safely disposed of by the Brunel technicians. So let's get into the actual project. So in this project, you are going to be designing a flying wing using Fusion 360 CAD. So it's a simple project which is going to involve aspects such as designing your airfoils, integrating your airfoils, and creating your wing. So just before we get into that, I'd just like to go a quick introduction to our airfoil creator which we're going to be using. So just a brief introduction to airfoils. When using this software, your camber is essentially your curvature of your wing, how biased it is towards the top or bottom of the wing. So a camber of 0% will be a symmetrical airfoil, with your camber line in lining with your center line, which is other known as the okay, it'll come back to me just now. So your max camber position is the point at which your camber reaches its highest point along the airfoil's length as a percentage. So if we change our max camber to 4%, we'll plot that. You can see we've now got a curvature to our aircraft. However, this is really close to the leading edge, as we are only 10% of our camber's position is only 10% of the actual length. So if we change that to, say, 40%, you can see we've created a more traditional aircraft shape. Sorry, excuse the ads that are going on. So we'll be going in this. You can now see your actual camber line along the top, showing how your so if it was along that straight black line in the middle, that would be the center of your wing in a symmetrical, your camber line in a symmetrical airfoil. Now you can see how we've changed that to be along the top of the airfoil, higher in terms of the actual camber line. So that's just the basics to that. I would encourage you, when you actually are doing the first part of the introductory project, to play around with this, see how your camber position all affects everything, and just have a good time just testing it out and being happy with your end result. So let me go back to the presentation. So in the next session, we are going to be going through taking the wings that we design and turning them into a design we can use for 3D printing. 3D printing, or Fusion FDM printing, Fusion Deposit Modeling, whatever. It is a very powerful system that we use to prototype and design our aircraft, and many different projects within BRES will make use of it. So for our full-size aircraft that we're going to, not full-size, but our scale aircraft that we're going to build for the vertical takeoff and lifting, we will be initially 3D printing. If further, we'll be using our 3D prints to create a mold for carbon fiber. So in our next session, we're going to be going through the specifics that we're going to be using in order to take the wing that we've created and turn it into a model for 3D printing. So without it, that's coming towards the end of this part of the first session. I've put in the WhatsApp group and on the Teams group the links to the Autodesk App Store, which has the plugin for Fusion, as well as Airfoil Tools, which is the online platform we're using to obtain our airfoil data. Lastly, before we get into the final part of the session, if anyone has any experience flying aircraft or model aircraft, we would like to, could you let us know, as it's always great to know how many of our members within the team have experience with these systems and flying them. So let's get into the next bit. So the first thing we're going to be doing is installing a Fusion 360 add-on. This can be found at apps.autodesk.com. In the sheet I provided, you also find a link to it. It is a Fusion 360 app called Airfoil DAT2 Spline. It is Mac OS and Windows compatible. So this pretty much just lets you download an airfoil's shape and install it into Fusion, rather than try guess your way around it. So at the end of the day, you end up with a more reliable document to use. So next step, once you've installed Airfoil DAT Spline, you can go back to Fusion. You can check your tools. You click add-ins, scripts and add-ins, and you should see under my scripts it's showing up here. Okay, so next step, once you've got to here, your next step will be getting a DAT file for an airfoil. For that, there are lots of programs which you can do that on. However, we're going to be using a really simple one that if you're doing second year of aerospace, this will be quite handy for you. It's called airfoiltools.com. So essentially this will generate your airfoil shape for you. So if you want, you can just play around with your values, your camber position, etc., your thickness. I'd leave your number of points to 81. The more points you have, the more exact your airfoil is going to be. However, we don't need it to be perfect for a scenario. Very important is to click close the trailing edge, which makes the final point down the end here, closing it rather than leaving it open. Then you click plot. Okay, now you see on the right here it has generated your DAT file. Okay, so we're going to select it all, copy, and then you're going to open up your text. In Mac it's going to be text edit, in Windows it'll be WordPad. So I'll first go for Mac scenario and then I'll show you using Windows. So you'll paste it in. Okay, you can now see your airfoil profile. Doesn't look like much now, but it just shows you all your points and it'll help you later on. So then we click format. Just to be sure, we click make plain text. Okay, perfect. And then file, save. Just close. Airfoil 1. Just leave it as Unicode UTF-8. Save. Okay, in Windows, using WordPad, we'll paste it in. Okay. You go File, Save as, Plain Text Document. And I'm just going to put it onto the desktop. Here you should be able to save it as a DAT. Okay. Okay. So now you'll see that it's saved as airfoil.dat. So it's now saved as a DAT file, which is what you need for install. So then you'll be able to use that in Fusion. However, on the Mac scenario, you have to go find it, Airfoil 1. It's showing as a text document. We're just going to go .dat, use DAT, sorted. Okay. Okay, now we can go back to Fusion. So once you've completed all of that, I'll go through the process again. We're going to go to Tools, Add-ins, Scripts and Add-ins, Airfoil DAT Spline version 2.0. Click Run. Construction plane. I will suggest using your XY axis. Just you can click under it under Origin on Fusion. So chord, for example, we'll just do 300 millimeters. Scale, and we won't have any offsets. Okay. Now you'll select your DAT file that you had earlier. So this was our airfoil that we created. Click open. Okay, so there you've installed it. If you click on it, you'll see it creates a profile. If this doesn't happen, it is highly likely that you may not have selected your closing your airfoil. It will be open at the end here. If that is an issue, you can just quickly click on it, create sketch, select it, project, Okay. And now you'll be able to close up your endpoints. Obviously I can't do it in this case as it's already all closed, but if yours isn't creating the profile, will probably solve your issue. Okay, so now we've got our initial airfoil. So in order to create our wing, in this example we're going to taper our wing back a bit. We'll select our object, construct offset plane. This will be half your wingspan. So in this scenario we will go 600 millimeters. You can use any amount you want within reason, but I'd keep it under 1000 millimeters. Okay, here you can see we've now got an offset plane. We'll now create a sketch on this plane. Tools, scripts and utilities, create, run. We'll select our construction plane, plane 1. You can see we've now selected it. It's found under construction, plane 1. Chord, we'll put the chord as the same as original line, 300. Scale, we'll halve it, 0.5. And offset on the Y. Let's X offset it. We'll add some dihedral and some sweepback, so we'll make both 10. Okay, so now we'll select our airfoil again. In this example, you can select another airfoil, which will produce a different airfoil at your wing root versus your wing tip, which assists in your stall of your wing, whether you can choose whether your wing's tip stalls first or your root stalls first. However, in this case, we're just going to keep it simple, keep it the same. Open. Okay. So now you can see we've got our second half of our wing. Well, our second profile to work from. So in this example, if we want, we'll add a winglet to the end of it, just for the fun of it. We will select our end piece, create sketch, and sketch. Okay, now just for fun we can, first things we've got to do is select our shape, create, project include, and project it. Okay, so now we can work with it right onto this new sketch. So we can go back to sketch, line. You can go probably as crazy as you want with this. However, I wouldn't, have fun. I'm just going to make something fairly simple here. Okay. Okay. So now we've got our end piece. So now we're actually going to connect everything. So to do this, we're going to go finish sketch. Okay. Select our first face. Create. We're going to use the loft tab. Our first profile selected. Then we'll select our second profile. Operation new body. Okay. If you look there, we've now created our half of our wing. Okay. Okay, it's gone and it's hidden our end sketch. In this case it's going to be sketch 3, but we're going to show it again. And we're going to extrude, select the 3 faces, and in this scenario we won't give it an exact, you can just take the arrow, pull it as far as you want or think necessary. In this case, let me just go with 3 millimeters. Okay, so there we go. For fun in this scenario, I'm going to just add a vertical stabilizer. Exact same process pretty much. We're going to select that face, create sketch, select, create, project. Okay. And we'll just create ourselves like a quick. This is your vertical stabilizer. You could add control surfaces such as your rudder and your ailerons to this model. However, for the process of doing a CFD analysis of this further on, it's not really necessary. If you're actually planning on flying it, like 3D printing it and flying it, you would cut those control surfaces in, but in this case we won't be doing that. So we'll just select here, solid, extrude. Important here is to select symmetric so that it extrudes it on both sides to make it even. Distance we'll go as being 3 millimeters again. Join. Oh, okay. Let me edit that one quickly, sorry. Edit feature. Join, it's going to be a new body. Okay. So I can hide the sketches now and give you a full view of half of the flying wing that we have created. Okay, so now we're just on the downhill. In order to finish it off, we're going to go under our bodies tab, just find out which is body 1, select it, that's going to be our main wing and our wingtip. Create mirror. Okay, mirror, we've selected our object, it's in blue. Now your mirror plane is important. Your mirror plane will be whichever initial plane you selected. Remember, I selected the XY plane. If you had selected or XZ or YZ, that is the plane you'll be selecting, but I selected the XY plane, so it's going to create another half across that. We'll join them, and there you go. That is your complete flying wing. We'll do further analysis and testing that in the next session, but that's it for now. If you have any questions, queries, etc., just give me a shout and I can easily help you through all of this or anything else. I'm always happy to help. Thank you very much, and thank you for joining, and looking forward to seeing you all soon. All the best. Thank you.